IT Solutions is a balanced staffing company developed by a group of professionals with an experience of over 18+ years in staffing solutions. With years of quality and committed high-end application development and staffing experience, we have become experts at delivering the right fit, the first time. We will be glad to be your last stop and provide you with the perfect solution to your requirements. Follow Scholarity Solutions LinkedIn page. For more updates, follow our social media pages.
Thank you for joining the session. As you can see on the screen, this session is organized by Scholarity Solutions. Scholarity is a IT solutions provider. It's a group of professionals and technical guys. They've created a group. They provide a robust team for serving various kind of solutions to the clients in the USA. So there are links available in the chat. You can follow them on social media. So we keep doing these kind of sessions on different technologies. So you will get an update when where the session is happening. So do follow them and provide your feedback on the articles as well. There are numerous articles that are written on the page for various technologies, so please go through it and be up to date.
As told, SQL Server AlwaysOn availability group we are going to talk about, and the specific focus will be on domain independent availability groups. This is Rohit. I work as database operation manager. I have over close to 12 years of experience now, 12 plus I would say, and I work on SQL Server, Postgres, MySQL, MariaDB, Mongo, Cassandra. We have several clients which my teams and I support on Azure SQL, and we also have presence in RDS. So you can follow me on LinkedIn, connect me on Twitter. I am a Microsoft certified trainer as well. I've been training on various Azure and SQL Server from years, and I have these handful of certifications. All right, so let's talk about AlwaysOn. I hope most of you are from SQL background. If not, then I would assume that you may still get a bit out of it. If not, then please try to stay and understand what it is, and might want to go back and check the regular availability groups and all. So I'll try to give you some overview about AlwaysOn availability groups. So we'll go a bit in depth in AlwaysOn, then we'll go ahead with setting up that topic of discussion today. So what is AlwaysOn? So AlwaysOn is by far the best HADR topology available within SQL Server. It was introduced back in 2012, SQL Server 2012, and so it's both. You can use it both for HA and both for DR. Now, what does it mean by HA? When you have multiple replicas available for your read and write workload. So read and write would be one primary replica, and then read you can have multiple different replicas, right? So that is HA. Now DR is when you have a replica which is readily available to take ownership of your applications, become primary in case your current primary experiences any issue, right? So that's DR. So that's by far the best topology available with SQL Server right now. In terms of HA and DR, you can achieve greater RPO and RTO with AlwaysOn because the failovers are almost instantaneous, right? And the data loss is almost nil. I would say almost, because what happens, if you have, let's say, you didn't prepare a proper HADR solution when you're putting your AlwaysOn availability group in place, and you put, let's say, you have your primary back on Eastern time zone, and you have your secondary which you are using as your DR, let's say in Asian time zone. Maybe like in my environment we have primaries which are in New York, and then we have secondaries which are in Hong Kong. So there is a latency, right? So if something goes wrong with your even your secondary, then you might have a bit of problem with your RPO, right? So but still, it's by far the best. You get automatic and manual failovers with always on availability group. You get multiple secondaries. You get active secondaries. That means readable secondaries, right? It has fast failover, less than 30 seconds, but again, it depends, right? How many databases you have, how big those databases are, and how transactional those databases are, right? So it just depends. And the configuration which you have. You have the default configuration for timeout is 10 seconds, right? It waits for 10 seconds before initiating the failover. But if you have, let's say, your network is not that reliable, and you pumped up that 10 second of, the timeout setting, then it may, you will have to wait for that particular time to, get your secondaries working as primary, right, for the failover. Now, AlwaysOn also gives you a great feature that's called automatic page repair. Now, what happens if you have some page level corruption, right, on your primary or even on your secondary, so they can help each other with recovering from that particular page level corruption, right? So that's what you get with that. Now we'll talk about the terminology around AlwaysOn. You get primary, you get secondary, then you have availability groups, right? Then you have availability replica. Now don't think that secondary you can just call it availability replica, right? Even your primary is an availability replica, because that's a part of your availability group, right? Now you have availability database. Now on the server where you have put AlwaysOn, right, you may have multiple databases, and now some of them might be part of AlwaysOn and some of them might not be part of AlwaysOn, right? So not every database will be called availability database. The database which are part of some availability groups will be called availability databases. So these are the terminology you should know about. Availability database, availability group listener. Now this listener is always points to your primary database for read-write workload, right? So it's kind of let's say aware of. So you get a point of contact for your failover cluster, right? Each individual node, a part of failover cluster, may have different IPs, but your failover cluster gets one particular IP, right? Same goes with group listener as well. Now you have availability modes. What different you have? Synchronous, asynchronous, right? Now you have failover mode. You get log cache. That's one of the best improvements. Let me check chat. All right. So that was one of the best improvements what Microsoft did with log cache in comparison to mirroring. So in mirroring, there were so many drawbacks compared to AlwaysOn, which Microsoft addressed, and then the log cache was tremendously improved in AlwaysOn. It keeps on increasing up to an extent when okay. So Chetan. That's Chetan. So Chetan asks a question: how does listener get to know which node is primary, and how does it send traffic to read only secondary? Okay, so listener, that's how this AlwaysOn work, right? So listener gets created on your failover cluster, and then in background, that's how the Microsoft came up with the concept of listener. So it knows that where to point your connection to. It always points that to your primary. Now, if you want to connect to your secondary, then you will have to specify some parameters like application intent, right? That you have to mention that, okay, in your connection string, when in your app, then this application intent, if you're using secondary, read only, then it will connect to secondary. And that SQL Server failover cluster, that's another terminology as part of AlwaysOn. So now AlwaysOn evolution. We'll just take a quick scan through this. In 2012, we had 5 replicas, 1 primary and 4 secondaries. We could have 2 automatic failover partners. That means 2 replicas in synchronous mode, right? Now 3 sync partners. So in 2014, you got 8 replicas. As you replica was introduced, you again have 2 automatic failover partners. These are secondaries, and 3 sync partners, 1 primary and 2 secondary, right? Now you got read intent one, where you could actually basically specify read intent in your application connection string, and then you can basically point your applications over to your secondaries. Now you had improved dashboard. In 2012, you could not add or remove some of the counters from your availability dashboard, but here you could. In 2016, the log transport performance was improved. In AlwaysOn, the compression and the encryption, greater encryption were introduced. You got to use round robin load balancing in readable secondaries. What you could do is you can create a group of your readable secondaries, right? Let's say you have 4 secondaries, and what you could do is you could put those all 4 in a group, and then what happens is when the first connection goes to your readable secondary, that goes to the first one. Now the second connection will go to the second one, the third will go to the third one, and fourth to the fourth one, and the fifth will again come back to the first one. So you could load balance your read workload even on secondaries. That was introduced in 2016. The individual database level MSDT support was introduced. Domain independent availability groups were introduced in 2016. But this is not really true about domain independent, the one which we are talking about. So basically, guys, domain independent availability group is a magic of Windows Server 2016, not really SQL Server 2016. But since SQL Server 2014 is also supported on Windows Server 2016, so you could even implement domain independent availability group on SQL Server 2014. Okay. But since this feature was introduced with Windows Server 2016, the concept of domain-less failover clusters. That's why most of the places you will only see that the domain-independent availability groups were introduced with SQL Server 2016, but that's not really true. All right. Now the automatic seeding was introduced with SQL Server 2016. You could have DAG, distributed availability groups. You could have up to 17 secondary replicas. All right. Readable secondaries, basically. Okay. Now you had updatable column store index support on secondary replica. The transport, TDE support. You could have basic AG support with standard edition. It wasn't possible before 2016, right? But it doesn't support HA and all. You can check for that. You have database level health detection here. Earlier it was AG level health detection, but from 2016 you could put this thing in place. All right. In 2017, read scale availability groups, which are called clusterless. You don't even have to have a cluster to create availability groups. All right. But since the failover is the feature of Windows failover cluster, if you are going with clusterless, that means you won't have HA. All right. So because you won't have, first of all, auto failovers as well, right? The cross-platform AlwaysOn support was introduced in 2017, and 2019 we could have 6 sync replicas compared to earlier 3 sync replicas. All right. Now Kubernetes support was added, and automatic routing to primary was added there in 2019. So any question here until now? All right. So how does it work? How does data synchronization work in AlwaysOn? You have your user over there, right? The user sends the query in, then the query is executed log by the SQL Server for that particular query, and that's put in the log cache in form of a log block, right? At the same time, that same log block is captured by the log pool and is also sent over to our transaction logs, right? Then the log capture service, which is running in background, pulls all the logs from your log pool and sends over to network. That's encrypted and that's compressed. All right. Now the log service running in background on your secondary picks that log up, put that in log cache, and meanwhile a redo thread which is running on your secondary will pull that particular log block from here and redo that on your secondary, and meanwhile same log is written to your transaction log, your secondary as well. So if you have your well, we'll talk about that later. So that's happened that's how the data flow happens within always on. Now, if it's a synchronous availability group, now we have two kinds, synchronous or asynchronous, right? So in synchronous, what happens is when this log block is written here in transaction, irrespective of the fact whether this was written or not, as soon as the log block has been written to the transaction log here, an acknowledgement is immediately sent to your user. All right. So that's in synchronous. Now, what happens in asynchronous one, when I think this, okay, yeah, sorry. In asynchronous, what happens is as soon as the log is written here for that particular transaction to the primary transaction log, immediately the acknowledgement is sent to the user, irrespective of the fact whether that has been written here or not, right? Redo is never considered in that factor, right? In acknowledgement, redo on secondary is never considered. That happens with asynchronous. As soon as the log block has been written to the primary transaction log file, we call it good. Now, what happens is when our always on is in synchronous mode and our synchronous secondary goes down, what happens in that case? So log block came here. Sorry. The log block has been captured by the log capture service, sent over, right? But your secondary is down right now. So in background, what SQL Server does, SQL Server automatically changes this synchronous to asynchronous, okay? And sends the acknowledgement back to user and sends it over, tries to send log over to secondary. If that's not available, it keeps on piling these logs up here in log cache. All right. That's how you might have seen, if you guys already have always on, that is the logs on your primary keeps on growing when your secondaries are down, right? So it changes to asynchronous and the acknowledgement is immediately sent, right? Now, there are so many different factors here which are extensive internals of SQL Server always on. We don't have that sort of time to explain that here, but there is something called flow control gates in always on, right? So when you have this kind of scenario, or your secondary is extensively slower than your primary and couldn't catch up, your redo thread is not catching up with your primary, then a concept called flow control gates comes into picture in always on, right? And there are two. One is availability group level of flow control gates and database level flow control gates. Those are logical terms in always on which controls the flow of these logs from primary over to secondary. But that's might want to hit that up on Google and see what those are, because that's again a lot deep in always on. Now, what happens when you create always on availability group in background? The first thing first, if you ever have created via T-SQL, you would know. If not, then you might not know that, because GUI hides almost everything, and you just want to see those green tick boxes when you create always on. Okay, everything is green, we are good, right? So what happens is, first of all, the endpoints are created. Now, what are these endpoints? Right? The endpoints are the communication channel between the server for always on, specifically for always on, right? So always on uses same endpoints as database mirroring used to use. Same endpoints, same port is used by the always on as well, right? So this is the traditional port is 1433 for SQL Server, but this doesn't use that one. It uses 5022. So that's the endpoint is like a backdoor channel which no one else can go through, but just always on traffic. All right. Now these are created, started, and properly permissioned. Now, what is the permissions? Your service accounts should have permission on those endpoints to send traffic here and there, right? Now, next thing the SQL Server does is it creates extended events, health monitoring extended events for always on. Now, still we are not creating, we are on that step where AG is created. Now, the third thing is AG is created on your primary. It's still not secondary, right? Then listener is created only if you are creating the listener while creating your availability group. You can create it later, but if you're creating it, the listener is created, then your secondary server joins your primary, your availability group, not before that. All right. So these are the series of events which happen when you basically create availability groups in SQL Server. Again, everything, whatever we have talked about until now is related to traditional, the basic availability groups. I mean, the regular availability groups, not the cluster, domain independent ones. Those are something specific we will talk about in a bit. Now, we talked about automatic page repair. Now, what is this? So if a page becomes corrupt in your database, which is part of AlwaysOn availability group, right? Now, SQL Server internet tries to fix that page with the help of secondaries. If the page is corrupted on primary, if page is corrupted on secondary, then with the help of primary, the page will be repaired on the secondary, right? Now, what pages cannot be repaired? Your file header pages, your database boot page, allocation pages, GAM, SGAM, or PFS. These are some things which cannot be repaired, which are beyond AlwaysOn. So basically, it sums up to the data pages. Regular data pages can be repaired with the help of AlwaysOn, and you won't even notice that. But the thing here is, it should not be some block level corruption. I mean, the hardware level corruption, right? It will still try to repair those. If can't, then you'll just get the error. Now, every every details of these page repair events are logged in this table within MSDTC. If you are using AlwaysOn or planning to use AlwaysOn in future, please do set up a SQL job which polls this particular table after every every particular duration, maybe every day, and sends a notification out to you, okay, that there were some page corruption in your database and was recovered, right? Because if you hit a corruption in your database, you might want to run a proper check DB, and you might want to ask your storage team to scan through your hard disk that everything is good, right? Well, that might be the initial indications of bigger corruptions in future. You might want to do that. Now, how it happens? So in the primary replica, SQL Server finds a corrupted page. Okay. Now, immediately it logs the entry about that corrupted page in your MSDTC database in this particular table, suspect pages. All right. The entry is logged there, and immediately a broadcast request. It immediately broadcasts a message to all secondaries about the corruption, that this page is corrupted, and it marks that page as restore pending. Okay. Now, whatever secondary, there could be n number of secondaries, whatever secondary replies first, I have a good page, right? SQL finds, okay, this secondary has a good page. Then it asks that secondary to send that page over and replace its corrupted page with that particular page from the secondary. Now, what happens if there are multiple secondaries which replies, I have a good page, I have a good page? Then the secondary which replies first gets accepted as the partner for page replacement or page repair, right? So that's what happens here. And when the page repair is done, the table suspect pages within MSDTC is updated with the details that page has been corrected, right? That's what happens when the page corruption occurs on primary. Now, when it happens on secondary, right? So same, the entry is made into MSDTC, and secondary again broadcasts a message. First, it checks with first of all, it checks the availability with the primary, whether the primary has a good page or not. Now, here comes the question. Now, what if primary doesn't have a good page? Well, if primary did not have a good page, first of all, primary would know, and it will automatically initiate this process. We won't even reach this process, right? Well, that's the most busiest guy in your topology here. So the same cycle, happens here. Right to MSDTC, ask for primary say, okay, I have a good page. get it, and it gets that from the primary, and then replaces it, updates the data in suspect page table, and everything is good. All right, cool. So that's how the automatic page repair is done. Now, guys, to make this presentation easy and to take least amount of time, what I did, I already prepared few virtual machines. I'm using VirtualBox as the hypervisor. All right, I have Windows Server 2019. Again, all evolution editions. All right, Chetan asked a question. It means the data replication at database level is similar to mirroring, and Windows Server failover clustering takes care of not failover switchover, right? That's right, Chetan. But can you explain what happens under the hood during failover from cluster perspective? All right, we'll discuss about that, Chetan. I'll address that. So, okay, I was saying, yeah. So what I did, let me pull my, I have this server here. That's my remote server, right? So I have, I'm using, as I told, VirtualBox as my hypervisor here. So what I have 3 virtual machines running here. One is my DC. So guys, since it is domain independent availability group, what we are going to implement here, we don't need a domain controller, right? But what I'll tell you why I use, basically we need 2 servers, one primary and secondary for our domain independent availability group, right? So what already I did, I created these servers. I installed Windows Server 2019. I installed SQL Server 2019. I enabled AlwaysOn feature there. I created failover cluster already, because if I were to create these all in front of you guys here, that's like 4 hours of job, right? So that's just too much. So I created this all. I'll guide you step by step how I did. Okay, I won't do that again, but I'll guide you how I did. If you guys have any issue, hit me up on LinkedIn, or put in the group, KT expert group. I'm part of that group. I sometimes answer people question. If you have any issue creating virtual machine, I'll help you with that. I can get you a documentation to set this up if you want to go and try on your own laptops or desktops, right? So I did this all. Now let's go back to our presentation for now. So okay, what I did, why do we have this here? Okay, let's put it back there. All right, now this was all about the regular availability groups here. Okay, now let's answer Chetan's question here. So Chetan asked, everything is handled by the Windows failover cluster. That's true, everything is handled by the Windows failover cluster. Now, what happens under the hood during failover from cluster perspective? All right, so what happens there? When the, let's see why we have to go, why even failover happens. Let's talk about that. So what happens, guys? We have SQL Server, right? Now, everything running on your system is an application, be it SQL Server or other application. Now, almost all application has their executable files running somewhere, or maybe DLLs and all. So what happens in background, your Windows Server failover cluster DLL keeps on pinging your SQL Server DLLs and other resource DLLs, right? So you have your memory, you have your CPU, and there is an application, there is a tiny responsible guy running in background, which keeps a track of every resource on your machine, right? Be it SQL Server, memory, or CPU, or everything. Now your Windows Server cluster, failover cluster DLL keeps on pinging all those resources. Now there is a timeout. There is a particular time when these service pings them every few milliseconds, every few seconds. We'll talk about that later. I'm just saying for now, every. So if it gets the reply back from those resources, it finds, it says, okay, everything is good. Let's continue the job, whatever we are doing. Now, if it doesn't get a reply from any of those resources, right? Now, it retries. It again didn't get a reply from that particular resource. It will again ping that resource after a particular timeout setting. Now, if it doesn't get that reply back, now it thinks, okay, now I have exhausted all possible retries. I won't wait for this. I think there is something wrong with this particular server. Let's initiate a failover. Okay. Now, when failover happens, what happens is that the ownership of these resources is taken away from your primary server, and then the failover failover starts in background. New secondary is elected. The election happens if you have multiple secondaries which are part of your DR strategy. Now election happens, whatever secondary is chosen to be the future primary, the ownership of the resources, what resources, SQL Server resources, your other whatever resources are run in background, is tried to be handed over to the new chosen primary, right? And when the ownership is being transferred, then your listener will get transferred and everything, and then the failover will complete. So that's what happens in background here. I hope that answer, again, not going into too deep, because how this ownership happens, what kind of polling is done, that's again will take time to I think that answered your question, Chintan. If not, I can definitely get you a detailed documentation later. Maybe we can talk, in group. Sure. Thank you. All right. Now, let me again pull that server back here. Okay. Now, I have two servers here, DIND1. Now, funny name again, but I use these kind of names, so I know when I'm going through my virtual box tomorrow. I have so many virtual machines. Which one I use for which one? Like DAG is for distributed availability groups. CLSAG is clusterless availability groups. So that's why I use these kind of names. So DIND1 and 2 are domain independent availability group replica first and availability group replica second, right? Now, what did I do here? First thing first, when you are creating these virtual machines, you have to have some sort of a setting done here so they can talk to each other. Because guys, how does two machines talk to each other in traditional environment? They have a middle guy, right? Negotiator. Now, who is that negotiator? That's your domain controller, right? Your domain machine. All your servers are added to one particular domain controller, right? In all of your environments, you must have seen, let's say, Microsoft.com, right? So each server which is part of Microsoft.com will have its name. Let's say a server name is server1. Now server1.microsoft.com. That's the fully qualified domain name for that particular machine, right? So Microsoft.com is a domain has been hosted on one or more, again, because it's a Microsoft, it's a gigantic, there's a giant there. But in your small environment, you might have a server acting as your domain controller, right? Taking responsibility of authentication, authorization for all these servers which are part of that domain, right? But since here we are not using any domain, that's why it's domain independent availability group. We aren't going to use any domain. So how do these two servers talk to each other? How will we set up always on? What settings are to be done? So first thing first, when I'll also, is anyone see servers? Saurabh, you don't see my screen? I'm sorry. Okay, I think I know the problem here. How do I change my screen? No, I don't want to leave the screen. Okay, I can change from here, I think. Let me share my screen, guys. I'm sorry about that. Screen. This one. Sorry, let me know if you see it now. Can someone write in chat if you see it now? All right, thanks, Shiv. So sorry, guys. I didn't really see if I was sharing my screen or some particular application. All right, so these are my different ones that I'm talking about. Now, these are the servers here, DIND1 and 2. I'll walk you through quickly what settings are to be done. If you are using VirtualBox, first thing first, use host-only adapters in your network, all right, for your virtual machines. Now, host-only adapter, what it does is, it helps your virtual machines talk to each other with the help of your hypervisor. I mean, the traffic, it's like if you guys are aware of loopback address of your routers, right? 127.0.0.1. Now, what happens if you are using that loopback address in any of your application? Now, the loopback address between your two applications. Now, what happens is the traffic is routed through that router and doesn't go to the real internet, right? It's same thing here. If you are using host-only adapter in your VirtualBox, again, it's specific to VirtualBox. If you are using some other hypervisor, maybe Hyper-V or something else, Oracle VirtualBox, I think. No, that's something, I don't know what this name is. So there you may have to use a different network adapter type, but here you use host-only adapter. You could use just one. I'm using two because I was testing something else. Same here, all right? So you need to, first of all, you need to use this one. Now, the second setting you need to do is just put an IP address with same subnet. I'll show you. I'll go to Ethernet. I have this one enabled here. Let me go take you to properties, and then come on. IP4. So I'm using this particular IP for this machine with 56 subnet. All right. So use this. I'm showing this. This comes into recording, and you might want to revisit this. So I'm using this one. Now for my DIND2, I'm using the next IP. Come on. Because creating Windows Server, creating payload cluster, and all that stuff would take a lot of time. So here, okay, so I prepared everything in advance. So I'm using same subnet here as well, all right? So they can talk to each other. Next. What you need to do is, in order to create your domain independent availability group, you have to have, come on. So you need to go to Windows System 32. Let me open this one. Maybe. All right, let me take you from here. There you go. So your C drive, then Windows System 32 drivers, etc folder, and you get this host file here. Now, what this host file is, this host file keeps details of all the servers which are not part of your domain, a single domain. It never, it doesn't hold that, but you can use this file to list the servers down here. Let me open this one. Let me show you. Open with Notepad. So you can list down all the servers here along with their IP address and fully qualified domain name, and then this server can reach out to those servers. So I used DIND1 here, right? The IP address and fully qualified domain name. Though it's a workgroup server, but we still have to have a suffix added to your server name in order to add your server to a cluster, domain independent availability group. So I used DIND1, so I can connect DIND1 from DIND2, right? And same way here, I added DIND2. Let me open this file. So I added DIND2 with its IP address here. Now, why do I use DC1 here? Guys, in VirtualBox, you see how this call is working. It's so bad here, right? So what I did, I installed SSMS on my DC1 just for the sake of demo and my testing, so I don't have to work with so bad mouse, scroll here. So that's why I added DC1 here. There is no second reason. That's the only reason I used DC1 here, because we will use SSMS on DC1. All right. Now, what is this DC1? It's my domain controller for other testing purposes, but here it's only being used for the sake of SSMS. I could install SSMS on any of these two servers, and we don't even need this server here. Okay, that's for the sake of this thing. So update this file here. This file can only be updated with local administrator. So log in with the local administrator, update this file with the different second server name and save it. After that, you just ping the second server. Again, guys, oh man, okay. I'm not sure what happened here. I might have hit a bad button or something. I'll bring it up. So let me show you from there. That one is also down. Let me pull this up. Not sure what happened here. I'll show you. I'll ping one of these. Okay, so let's go back to presentation for now. Okay, so prerequisites for domain independent failover cluster. All the servers must be running Windows Server 2016. That's the main prerequisite here. All right. Accounts that will be used to create failover cluster needs to be local admin. Now, what you must do, you must create a local user with same name and same password on both or all the servers which you are going to add as part of your domain independent failover cluster. Okay. Now, same password, same name. Now, DNS suffix for all participating nodes must be same. Now, what is this DNS suffix, guys? Give me a second, guys. I have someone. All right, I'm back. Sorry, what's happening here? Let me open this one. Something went wrong. Okay, so go back there. The DNS suffix I showed you guys, where I had dne1.domaind.com, right? So domaind.com was the DNS suffix. It must be same for all participating nodes. Again, you must have seen that the name for DC1 was dc1.wincnu.com. That was a different one because that's not part of our domain independent availability group. That's just helping server outside AlwaysOn environment, which I'm using for SSMS purpose. That's the last time I'm talking about this. I won't again, so just keep remember that. All right. Now, you must change a local setting that's called local account token filter policy for the local users here. So what happens, guys, in regular failover cluster, which we create for regular AlwaysOn availability group? Now the clusters are created with the help of a domain user, right? Now the domain user automatically gets all the privileges on all the machines. You can use same user to create everything, to do everything on all your machines. But here we are using local users, local admins. Why? Because there is no domain. There is no a middleman there to authenticate your users on a different server, right? That's why we need to update this policy on your OS level and allow this policy so the local admins of a different server can create failover cluster. That's again Windows failover cluster, not SQL Server. All right. So cool. There we go. Let me log in. So this is my local admin here, SQL admin. Okay. I use same name and same password on both servers, be it 1 or 2. Okay. See here again, SQL admin. Create this user, add it to local admin group on your OS. That's the one thing you need to do there. Okay. I also have same user in my domain controller. Okay. So I don't come across any user limitations, same user, same password. All right. Now, once this is done, we can go ahead and start creating our availability group there. Okay. Now, this is backup. I already show you the host file, the IP address. One more thing you should remember while creating, I mean, that's again for testing purpose, because I expect that most of you would be from SQL background, right? So you might not be that good with Windows features. So if you are going to create this one, please, I'll tell you some settings which will help you to, not come across a lot of problems on your Windows end. Just disable your firewall, okay? and disable your Internet Explorer security. You might have to download some things, so it will be a pain. So disable this, disable firewall. These are two things you should do as soon as you create your servers. Now, okay, what do we do next? Let me open it here. So these scripts will be provided. I'll send these over to Karthik, and if you need, then you can get it from, you can check with him and you can get these scripts. So on node 1, I already ran these again. I'm just going to do the always on stuff here, not the rest of these things. So you saw that that suffix, the suffix domain ind.com. So you can use, again, I use SQL admin, but you can create any user. So the user is created with this script. You use here SQL admin, then the password you can give. All right. Use this script to create that user, add that user to your user local group on administrator group. Again, same password across the servers. And this is the command which you can use to update local account token filter policy. Now set its value to 1. Okay. Now it will allow your local users to create failover cluster on Windows. Okay. Now after this, some more settings for your DNS suffix in your on your server, and then restart server. So this has already been done. So I'm not going to go deep into this. You can get the scripts. Now I'm going to do this. All right. So let me connect to these servers here. Okay. So I'm opening SSMS on DC1 because it's I have installed guest at this guest edition here on this one. So CPU works, mouse works better here. So I'll open SSMS here. I'll connect to both of those servers from here, and we'll do everything from here now. All right. So I'm going to join, connect to DIND1 and 2, both of these. Okay, one more thing. While you are there, before you could create your AlwaysOn, right? I already installed SQL Server, regular SQL Server installation, nothing fancy there. The only thing you need to do is you need to enable AlwaysOn feature. Come to your configuration manager, SQL Server configuration manager here. Okay, right click on the SQL Server service, properties, availability group. Now enable AlwaysOn. So I have already enabled that, and this is my failover cluster name. Okay, let me show you failover cluster as well. So guys, after you created your local user on your server, okay, so first thing first, what you need to do is you need to disable firewall, you need to disable Internet Explorer security, then change your server name from here, computer name, initially the computer name, whatever name you give here, that's a different thing, but whatever name shows here, it will be a random name. Now go in there, click on change, update this name here, okay, click on OK, and it will ask for a restart. Give a restart to your server. After that, you do same on second server, update your IP addresses. Once this all is done, then you have to go to tools, manage, add roles and features. Next. For now, you need to install, okay, next, failover clustering, okay. You install this feature here, next, and install. That's the thing you need to do on both of your nodes. Once that's done, you will have to, you will get this kind of fellow cluster manager feature here. Open this feature. Okay, then also before doing this, make sure that you can ping ping each other from, from the node 1 to node 1 to node 2. You can at least ping those both from either side, right? So just ping 2. Okay, so the ping is good. All right, so make sure your otherwise your connection will fail, your failover cluster will fail. All right, so I can ping, then right click and just validate configuration. Okay, you can just add both of your servers here and next. Okay, let me just show you for the sake of okay, I got both of them. So I have domain ind.com. That's again, it says no domain here. This is just a DNS suffix. All right, next. Now, since we are not going to create SQL Server failover clustering, but SQL Server always on top of Windows failover cluster, then you don't have to run all tests. You just run selected tests here. If you are going to use SQL Server failover clustering, not always on top of Windows failover cluster, you have to use all tests. Okay, for always on, just remove storage. Okay, and then just next and validate configuration. Once the validation is done, create your cluster, give any name. Okay, make sure to keep an IP ready for that. Again, guys, if you have any issue, if you come across any issue with this, hit me up on our KT Expert SQL Server DBA group. I'll help you out. All right, since I already have a cluster created, I'll just connect to my cluster. Okay, so I'm connecting to my cluster here. So I have cluster, my cluster name is no domain. Again, a funny name, but it helps to, remember me that why I created this one. So right now, I don't have any role here. Okay, no roles. I have 2 nodes as part of this failover cluster, 1 and 2. Okay, no shared storage because that's again a concept of failover clustering. SQL Server failover clustering, not always on. All right. Network, as I told, host-based, host-only adapter. So I have 1 cluster network. That's it for the cluster end. Now, after the cluster is created, just update your configuration from here on both servers, and good. Now we are good to go with in creating our domain independent failover cluster. Sorry, availability groups. Beg your pardon. So let me open my scripts, work group AG. Well, so when we call domain independent availability group, there are multiple combinations here. Either both servers are part of no group, no domain, just work group cluster servers, okay? Or one server is work group cluster, other server is part of a domain, or both are part of domain but different domains. So it helps everywhere, okay? You can use it anywhere. And the best thing is it uses Windows failover cluster, so you get HA and DR both. Okay, so on node 1, I'm not going to run this command. You might want to do that. Now, what I'll do, first of all, I'll create. Now, guys, if you guys are familiar with again workgroup mirroring, workgroup database mirroring, you might already know how we used to do that. If a server, again, we just updated host file, right? So these can talk to each other, but DIND1 still doesn't trust on this guy. We can talk to each other, but I didn't trust you. Now, how this trust is built, right? Because if we have a domain, then domain takes care of trust. There is no domain, so there is no middleman, there is no trust. Now, what we do, we will create our endpoints, then we will create some certificates. We will create encryption keys and all. Okay. So with the help of encryption key and encryption certificate, we will install certificate on each other. Okay, DIND1 certificate on DIND2 and 2 on 1. Now it's like I'm loaning something to you and you are loaning something to me. Now we both trust each other because we have something of value of each other with us, right? So we will create. So we have this stored procedure. What it does, it creates endpoint, it creates a certificate. Okay, it encrypts that endpoint with that certificate, and then it backs that certificate up to a particular shared location. All right, so what it does, let me show you here quickly. It creates a master key for encryption. Okay, now it creates the certificate, encrypt that certificate with the master key. It creates the endpoint and encrypt this endpoint with this certificate. Okay, so the traffic flow is encrypted and trusted. Okay, then it backs that certificate up to a particular shared location. Here I'll do this on both the servers. Okay, this is on 1. Now let me do on 2. So let me run this stored procedure, created this stored procedure. Done. Let me run this one. So now I'm creating the certificate. I'm using this password. You always use a strong password for encrypting your certificate. All right. Now creating this. Okay, done. Let me show you here. Come on. So I have temp on my C drive here. Okay, here I got my certificate. All right, now let me show you on here. If you might be wondering if I already have these here too. Now in my temp on DIND2, I don't have anything, right? Its folder is empty. Now let me create that on another one on DIND2 as well. Okay, done. Let me first show you. The certificate will appear under master. You must already know that. Here I have system certificates, but not our created certificate, but on DIND1 we created. Now you can find this certificate here, right? Right there. We don't have it here. Now let me create the certificate. Let me change the shared directory to this one and create this. Okay, now let's refresh this. Created. Now let me show you the endpoints as well. Endpoint data mirroring this. There you go. So the endpoint was created. AlwaysOn EP. Right. This one. Port. Right. And authenticated, encrypted via this certificate. Now, what if I want to drop this certificate? Sorry. What does it say? The certificate cannot be dropped because it is used by one or more endpoints. Okay, just to show you that yes, this endpoint is encrypted with this certificate. All right. Okay, now we have this on here as well. Now let me copy these certificate on each other so we can just restore them. Guys, we could automate this everything. I did one mistake, to be honest, while I was installing SQL Server here. Now the mistake I did was I forgot to give volume maintenance permission on DIND2 to the service account, SQL service account, right? And I didn't have time before this demo to fix that up. So I just need to copy this one. So I'm going to copy DIND2 to my server here on 1. Okay. Continue. All right, now I'll copy this one to another server. Okay. Then what we will do right now is we will install this guy certificate to this guy and this guy certificate to this guy. Now they will trust each other, right? Now how do we do that? Let's open another one. This import certificate to other nodes. All right. So I'll import these certificates on each other. Now we are on DIND2. So on 2, we will import certificate of 1, okay, from local location. So import certificate of DIND1 to DIND2. All right, let me create this stored procedure and let me run this particular statement. Now you see here, you have got certificate of this guy, right? Now let me take you there, refresh this one so you know that there is nothing for the, let me change it to 1, create this stored procedure. Now still let me refresh to make sure that we don't have it there. Now let me install that. Okay, now we have got this. Now they will trust each other because they have each other certificate. The encryption, the authentication on endpoints can be decrypted with the respective certificates. Now it's time to create availability group. Okay, guys, this thing cannot be done via GUI. You have to use PSQL for that. Okay, now I'm going to use SQL CMD mode, so I could connect via one on both servers via one window itself. I'm using SA to create this all stuff. So what I'm going to do here is, I told you first thing first, the endpoints are created, which we already did. The second thing is the event session is created and started. That's what we are going to do now. Okay, so I'm going to create this first on DIND1. Done. Let me show you one more time to make sure that you guys don't think that so all right, sessions, you have got on always on health here. Let's see if we have it here as well. Okay, sorry, I already created, I think, earlier, that's why we have it here. Now again, I'm starting this one. So done on 2. Now what I'm going to do is, I'm starting a trace. This trace will be used if you are using automatic seeding. So you can use this, you can watch the seed progress. All right, so start this trace. Then I'm going to create a new database here, which we don't have right now. You already saw, right? No database here, no database here, right? I'll create this database. I'll back this database up. Then I'll create my availability group, which we don't have here right now on any of these servers, right? The backup preference is secondary. You can use any, I mean, primary or whatever. Failover condition level is free. Now, what is this failover condition level? We'll talk about. Health check timeout is 30,000 milliseconds. DB failover is on. DTC support is none. Okay, you can use per database or whatever. For database, this one, whatever we created here. Replica, mention both replicas here. Mention endpoint URL. Okay, this would be your fully qualified domain name and your mirroring port. That's 50422. Basically, endpoint port. Okay, failover could be automatic or manual based on you. Availability mode can be synchronous or asynchronous, again, your choice. Backup priority could be 60/40, whatever you want. Okay, now if this server becomes secondary, you allow read-only connections, yes. Okay, session timeout 10 seconds. You could have 15, 20, leave this default is best. Automatic seeding is seeding mode is automatic, so database can be seeded. Now let's do that. Okay, connect to my DIND1 and okay, so DB was created here. Okay, a backup was taken because that's the first thing to do after you create DB. You take the backup, so it's ready to be added to availability group. Then the availability group was created, and for this database, it means the database was added to the availability group. Okay, now here you see synchronized. Let's refresh availability, always on. We have our availability group. We have our availability database here. We have our availability replicas here. Now, why secondary is still disconnected? Because as I told first, that first the availability groups is created in primary, then the listener is created, which we didn't do here, right? Now let's do the listener. We'll do it. Well, let's talk first. Then the listener is created, and then the secondary is added to the availability group. Now, if you refresh it here, you don't have the database, right? If you refresh on secondary, you don't have availability group here, right? Now let's create listener. Let me change the IP here. Might have an entry for 162. Okay, the listener port is going to be same because listener is the public space, right? You connect to listener, you don't connect to endpoint because endpoint doesn't know you. Okay, so again, creating listener. When you create listener, it creates some entry on Windows end, right? So that's why it's taking time. Basically on cluster. Okay, let me show you. Okay, let's go to role. You must have got, okay, my new AG. You got that role here now? So that's our AG, my new AG. Okay, now let's check for listener. We have got our listener. All right, now we will add our secondary to our availability group. Okay, now alter availability group new AG join on secondary. We are going to run this. Let's do that. Okay, now if you refresh it here, it should, okay, it is in synchronized mode right now. So guys, we have gotten ourselves a domain independent availability group. So that's how we do it here. Okay, now let me refresh it and it should show in synchronizing. Okay, so we are good with this one. Let's talk a bit about other stuff. Other means let's go back to our presentation. So we created login, we already did that. We added DNS suffix, we updated our host file, we disabled okay, this is this thing which I told you about here, right? Host only adapter. So I made it simple for you guys to understand from the PPT itself. A disable net rule or anything, just use host on adapter, install SQL Server, enable always on feature, install failure cluster, create failure cluster, create and backup your database, create endpoint certificate on all nodes, install endpoint certificate on all nodes, and create your availability group. Okay, now always on internals. Talk about always on internals. I'm sure you might, some of you might know, some of you might not. So I'll try to give you a good introduction to these internals. This will help you. Now, when you create always on, right? Let's say right now you have a primary and a non-readable secondary. In that case, what happens is that everything works fine. As soon as you change your non-readable secondary and mark that as your readable secondary, there are some changes which SQL Server does in background. Now, what is the first and foremost change? The biggest change is it adds a 14-byte blank space to all newly added, updated, or deleted pages. Newly, I'm again forcing newly added. The time when you change your non-readable secondary to readable secondary, a 14-byte free space is added to each page on your primary, because read and write is done on your primary, not on your secondary, right? Now, why this? What is this 14-byte is used for? This 14-byte is used to store row versioning information on your secondaries. Now, what is row version? When you have a readable secondary, right? You are using that for read queries. The changes on your primary must not block you on your secondary. So what SQL Server does, SQL Server keeps a track of versions. It uses version control for all the data which is being changed on your primary, so it can give you a consistent copy on for you on secondary. It can make that readily available for you for your queries, right? So a 14-byte is added in background, right? Now the biggest question comes here. Let's say Now let's try to relate these things here. You are using 100% fill factor for your data pages and indexes, right? That means SQL Server is trying to fill your page as much as it can with the data, right? Now, you have that setup in AlwaysOn. You have 100% fill factor. You change your non-readable secondary. A 14-byte free space is added to each page. You have, again, 100% fill factor. That means as soon as you are updating data on one page, which was 100% full, as soon as you send first update to that page, a 14-byte will be added. You will have extensive page splits in your database, internal page splits. Page splits means internal fragmentation. Internal fragmentation means you may have bad performance on your primary as well as on secondary, right? See how it all relates internally. So that's one thing which happens. Now, when you have a read replica, SQL Server upgrades the isolation level on your secondary to read committed snapshot isolation level, so it can get you a snapshot of read committed data on your secondaries for your readable queries. Now, since it's now using version store, that means it's using your TempDB for version store, must keep an eye on your TempDB, because now as soon as you change it from readable, non-readable to readable, your TempDB is going to be a store for version store. Now it's going to get used way more than it is regularly used. Okay. Now, next internal stuff. So fragmentation, I told you how this could lead to a bigger fragmentation because of your fill factor being 100% or maybe 90-95% and addition of those 14 bytes of free space. All right. Now, what happens is, one more internal about AlwaysOn. You have your primaries, you have your secondaries. On your secondaries, you are running read workload, and it is possible that you may not have indexes on all of your columns which you are using in your queries, right? There could be some columns which you might not have indexes on. That means you don't have user created statistics on those columns, right? Then you might also not have system created statistics on those columns. So what happens is, if you are using such columns in a query which do not have readily already created statistics, SQL Server in background creates some temporary statistics on just secondaries and store those statistics on TempDB again on your secondary to help speed up your readable queries on your secondary. So that's again one internal. These statistics live until you restart your server secondary, basically. Okay, they live on your TempDB. No more use of TempDB. You should be way more cautious with TempDB when you are using readable secondaries, because you will have extra statistics there, you will have version control there, you will have fragmentation, you will have a lot of things, right? Now, one more thing, ghost records. So what happens is, when you are basically using these version control, how does it matter? So when you have these version stores, these things, and you deleted some data from your primary, but a thread is already reading the data on secondary, right? Then primary cannot remove that data from itself, right? Those are marked as ghost records, and SQL Server keeps on checking whether we can drop those ghost records from the buffer or not, right? It periodically checks that. Once it finds, okay, there is nothing which is running on secondary which is still using that data which is part of this ghost records on primary, it will drop those. So even on primary, you must keep an eye on your database performance because of these ghost records and all. Okay. Now, these are some more settings which I want to talk about. Failover condition level. So first of all, once you create your your availability group, change your failover count from 2 to 10 or whatever per your environment, how stable that is, so you don't end up exhausting the default failover counts on your primaries. Let me show you. So go there, properties, failover, this. Maximum failovers in a specified period, just bump this up to 5, 10, 20, whatever you want in a specific period. You want to allow failback or not, that's up to you. Just change these settings. All right, these are the important things. The first thing first, to change that one there. Okay, AG session timeout setting, you gotta change that too. Okay, I clicked it wrong place. Now what that setting is, talking about properties. I'm talking about this particular guy here. You might want to change this setting if you want. Okay, so these are the two settings which you should change. Now, what are these last three settings? Least timeout. You must have heard about least timeouts. When your resource DLLs, your fellow cluster DLL cannot reach out to any of the resource DLL, that time the lease might expire. The lease is, what happens is, when you run always on availability group, your Windows fellow cluster DLL keeps on polling all resource DLLs. Again, as I told you about SQL Server resource DLL, your CPU DLL, your memory DLL, as soon as it doesn't hear the response back from those DLLs, it here's the response back, it renews the lease. What happens is, it gives a lease for all the resources, right? It needs like a kind of a handshake. Okay, you are alive, I will not touch you for let's 10 milliseconds, next 20 milliseconds. If I don't hear back, then I'll try 2 more times. If not, I'll expire my lease with you. Okay, that's the time when I'll start the failover. Okay, so that's called lease timeout. You might, if you have unstable environment where the resources are extensively used and might get blocked by some process for some time, might want to up your lease timeout. Failover condition level is that under what conditions Windows failover customer will start the failover. Okay, failover condition level 1, when your SQL Server that's the least. Let me pull a Microsoft documentation so I can tell you quickly about that. Sorry, I don't have that available, so I can read that for you. Failover condition level. Okay. Policies. Well, I'll give you an overview. So the level 1 is when your SQL Server service isn't running. In that case, it does the failover. If you have level 2, if you see here, I use level 3. Level 3 means there. Where did that? Yes, failover condition level 3. Level 2 means your SQL Server service running but is hung. Then it will start failover. Level 3 means SQL Server service running. The service is also running, but it also checks for your master database. Okay, if there is any issue with any of these 3, it will initiate the failover. Level 4 and 5 are the most restrictive. The 5 is the most restrictive one. Even if you have a deadlock in your SQL Server, that will still initiate the failover. So always understand the failover condition level here, so you know when how the failover happens and all. So these are some of the settings which you might want to configure post configuring your AlwaysOn, so you have a better and stable environment there. All right, guys. So this was all from for today's session. I hope you understood a bit. If you have any question or anything, you could post here, or you might want to talk in in group, and I'll be happy to help. So, guys, thank you so much for joining today's session. I hope you understood a bit, or whatever, out of this session. And please do share your feedback on LinkedIn link, which Karthik just posted in our chat, and we'll happy to hear from you. All right, over to you, Karthik. Thank you so much, everyone, for joining today. Karthik, you there? I'm not sure if he is. All right, guys, please do post your feedback, and hit me up if you have any question in our group. All right, thank you so much. You all have a good day.
Thanks, sir. Thanks. And guys, please share your feedback by the link provided in the GoToMeeting chat box.